Hey statisticians, I just want to go through with you what a scatterplot is, what you use it for. So you should have read for homework some of these things already, and you've already done a scatterplot, I hope, using your temperature data. So what I want to do is talk about how you would describe a scatterplot. What are the things you need to talk about? So first, a scatterplot is used to look for an association between two quantitative variables. So before you go making a scatterplot, make sure that you have quantitative variables and you have two of them that are attached to one another. So for the temperature data, for example, each pair of data were the monthly temperatures for January from two different cities and then February from two different cities. So they are inherently matched together. Which is what allows us to make that scatter plot. And then we're going to visually see if there's some sort of association between those two things. So one note here, and I've mentioned this before, but it's worth mentioning again, there is a difference between association, the word association, and the word correlation in terms of the meanings. So just be careful that you don't say the word correlation when you mean association. Up till now, and until we talk a little bit more about correlation, which is coming up later today, every time you've said correlation, you meant association and should have used the word association. So just make sure that you're using this where appropriate and not this. You're going to use the word association far more often than the word correlation. So just a couple of things. You're going to see these terms explanatory variable and response variable. The explanatory variable, when you make your scatter plot, is the one that's going to go along the horizontal axis, which you may think of as the x-axis from algebra. And the response variable is going to be the one that goes along the vertical axis. I think of these I think of the explanatory variable as the one that you're going to use to make the prediction about the response variable. So the explanatory variable is the one that's the predictor, and the response variable is the one that's getting predicted. So you could think about it that way if it helps you as well. These aren't terms that come up very often, but just so you know, in case you see them, that's what we're talking about. So this is the variable that explains this. And I'll go back to this once we've done an example. So when you go to describe an association that you see in a scatter plot, so when you go to describe a scatter plot, just generally speaking, here are the things you should talk about. So you want to make sure that you're doing this in context. And as with the descriptions for quantitative distributions, or the distributions we've already talked about, we want to do this in context. So you should not be starting your sentence off with the graph is or the scatter plot is. What you want to talk about in context is the association between blank and blank. And these will be filled in with your whatever your two quantitative variables are. So for your temperature data, you will start off saying something like the association between the average monthly temperature in Ithaca and the average monthly temperature in, I don't know, Florence, Italy is. And then you'll talk about the following things. So again, in no particular order, you want to talk about form. So you want to look at the scatter plot and see, does it appear reasonably linear or does it appear to be curved? And then you want to talk about direction. Is the association positive or negative? And then you want to talk about strength. So when you talk about strength, what you're looking at is how scattered is the data in the scatter plot? How scattered are the points? And then you're going to say things like strong, moderate, weak to describe that strength. And then you want to talk about unusual features. So if there are any outliers or clusters of outliers, so if there are any points that, again, that stand out, maybe deviate from the overall pattern, or follow the overall pattern but are really extreme in both the x and y directions. And then you'll also want to give an interpretation in context of what it means for the association to be positive or negative. So let's take a look at an example. So here's a scatter plot that's in that spreadsheet of temperature data. So here, if I'm going to describe this scatter plot, so I would say that the association between the average monthly temperature in Syracuse, New York, and the average monthly temperature in Madrid, Spain is positive, linear, and very strong. Keep in mind that we're going to add into this a little bit too. We're going to talk about a way to quantify that strength right there. So we've got it's positive, linear, very strong, and generally speaking, as the temperature rises in Syracuse, New York, the temperature in Madrid, Spain also tends to increase. For that last part, it's important to note that I did not say when the temperature goes up in Syracuse, the temperature goes up in Spain, because that's not a true statement. So there are points here, right here, the temperature went up in Syracuse from here to here, right? The temperature went up in Syracuse, but it did not go up in Madrid. So you want to use things, again, you always want to use those wiggle words. So you want to say things like generally speaking, or it tends to happen, because it's not an absolute. It is not 100% that if the temperature went up in Syracuse, that if there was a higher temperature in Syracuse, that there was absolutely a higher temperature in Madrid. So you don't want to make statements that make it sound like that's always the case. So you always want to throw those wiggle words in there.